So, as I said, I currently work for Costain in Costain's consultancy arm. I work for Costain and external clients on carbon-related goals and also BREEAM assessor. Before that, I was a Temporary Works engineer for Kia, Temporary Works advisor, and as such, I'm also here to represent the Temporary Works Forum. So, the Temporary Works Forum provides authoritative guidance and, when required, professional leadership to the industry. We also consider aspects of permanent works and interfaces with, and we're also aware of trends and innovations with strong links to research institutions and universities. So today, apart from imparting a bit of knowledge, I'd like to encourage everybody, whether you're in construction, permanent works, temporary works, just to collaborate by getting involved in the Temporary Works Forum. Collaboration is the key to tackling this huge challenge. We can't engineer our way out of this. And if we don't, other professions will do. And as we know, being a follower is always more expensive. So why temporary works? Why innovation? The thing I love about temporary works is that you're the judge, jury, and executioner of your work. You're involved over the whole process, from planning, conception, all the way through to final design, completion. Obviously, temporary works is not permanent, so it's great for innovation. We can fail fast, fix fast. In terms of innovation, it feeds on iteration, learning, and continuous improvement. So the faster we make these cycles, the more improvement we get. There's also greater opportunity to use a wider range of design codes, so we can follow international standards where better. A great example of this is bass-out reinforcement, where American codes allow for greater crack widths. And we can use these codes in temporary works. Again, durability is less of an issue, so there's fewer blockers to implementation, such as insurance and asset owner long-term risk. So as you can see, there's a huge opportunity in temporary works for us to fill. Let's not do it siloed in our own organisations. Let's do it as a group, like the Temporary Works Forum. So this slide attempts to look at the scale of carbon reduction in the turquoise bubbles. So it's the size of the bubble is the bigger the opportunity of various strategies, from green materials to use less stuff to innovation. The purple line looks at the perceived cost and difficulty of implementation. So, as such, at the bottom, an outcomes-focused organisation, company or project would spend most of their effort prioritising use less stuff and also designing for the end of life to save carbon now. But there should really be a keen interest in innovation as well. So one eye should always be on innovation, because we're not going to get past our 2030 targets with current materials and current techniques. In reality, however, we still see a huge emphasis on using green materials. I see this in all of my projects, whether it be contracting, consulting, or design. On day one, the conversations, the primary focus is always, can we use GGBS? Can we use wall mix asphalt? It's always on materials. We're looking in the wrong place a lot of the time. And if this is the case in temporary works, where there really are very few blockers, then the whole industry isn't moving fast enough. So today, I'd first like to talk about the effort put into date on redressing the current carbon balance. My laser's on now. So redressing the current carbon balance away from green materials to use less stuff and designing for the end of life. And then later on in the presentation, I'll talk about innovation in more detail. Okay, so in terms of current carbon, the industry has been putting in a huge amount of effort into correcting the overestimation of green materials with quantification, and then addressing the cultural challenges of moving away from business as usual. So, starting with quantification, the Temporary Works Forum so far has been looking at clarifying certain macro points for individual decisions. So this might not be a big deal comparing a project to another project, but for a graduate or a practitioner, it's really key that we get the macro calculations correct. So far we've completed a calculation of temporary works wastage guidance. So where other guidance available suggests hired equipment should be ignored or perhaps put in the bin, 100% waste, we've tried to clarify that point. We've also started to work on plant emissions guidance that doesn't exist anywhere else. It's really, really difficult to produce a kilogram of CO2 per meter cubed of excavation, for example, and that's something we're trying to address. In terms of business as usual, so defining a baseline for a macro carbon calculation, it's really difficult. It's very fluffy, and savings are really easy to come by if we do it wrong. And then lastly, in terms of quantification, we're trying to produce guidance on using corporate tax loopholes or not using corporate tax loopholes, such as only looking at scope 1 for HVO or possibly classifying GGBS as a waste material rather than correctly as a co-product. On the right-hand side, so from a behaviour perspective, businesses and organisations have been working really hard to create an ethos around curiosity and humility. There's heaps of guidance coming out of groups like the Net Zero Bridges Group, the iStructD, and the Temporary Works Forum on how to design the lowest carbon option. But we still need practical advice, specific temporary works guidance on things like concrete and haul roads. Smith mentioned earlier at the very start of this presentation that the biggest challenges to contractors were how to, which is the guidance, and collaboration, which is the working groups. We aim to address both of those points. The items in green on this slide are resources that we would like to create in the Temporary Works Forum, but we're a really small group. In a minute, I'll go through Costain's journey specifically on Temporary Works Concrete. And if anybody wants to help me make this or other green elements on this slide industry guidance, then please reach out. Why do we have the same guidance in every organisation when we can just do one? So, designing out temporary works is best viewed through the eyes of the Temporary Works Forum Guide Constructability, a guide to reducing temporary works, TWF 2020. So there's not many engineers that will talk their way out of work, but temporary works engineers will. We're more than happy to work with permanent works engineers for the best solution. This example in the picture here is similar to a Costain project that we're currently working on, where tunnel cross passages have to be created between the two tunnels, and support frames are used to support in this localized dig. We replaced these support frames with strengthened precast rings locally, and this reduced carbon, cost, program, but more importantly, safety, with clearer access and egress to the tunnel head. Okay, once we've got rid of the item, which in temporary works generally means getting rid of the virgin item and using hired equipment, such as the hacky staircase here, we work on reducing the geometric quantities of the virgin element, which is the footing for the hacky staircase, which we have left over. Our engineers at Costain now always question the design brief in temporary works. And in this case, the engineer has used a lower loading than the usual maximum allowable loading in the brochure and saved 56% of the remaining carbon in the virgin concrete element, which is the footing. The risk to the workforce was lower, less concrete to break out in 3 weeks' time, reduced hand-arm vibration, reduced silica dust, and the failure mechanism of settlement rather than disproportionate collapse is well understood and safe to do so. The controls that were put in place are scaffold tags, something that anyone that's been to a construction site will rarely walk past without a passing glance. Okay, so once we've reduced the volume of the virgin element, now we need to reduce the carbon intensity. This section was born from 2 Cambridge University master's students that spent 2 summer placements on Costain projects, analysing the wastage in concrete through the whole pathway. This included specification, material selection, batching plant rejection, and overstrength cubes. They really looked at everything. The results were quite surprising to us, and it ended up with us changing our standard drawing notes for concrete. So we now only specify strength for temporary works items unless there's technical justification. And this allows the concrete supplier the flexibility to change things such as slump without being handcuffed by water-cement ratios. We've also mandated the use of non-CEM 1 mixes and completely removed the use of ST mixes from all of our drawings. Now, although these are a few examples where mandating works over education, as you can see here, the heavy hitters of voids and freeze-thaw classification and chlorides still need engineering judgment, still need training and guidance. So in temporary works, it's unlikely that freeze-thaw or chloride classification will be required for temporary works, and voids should be considered in all cases. When we talk about voids, I'm not talking about polystyrene generally or per se. Perhaps we could use a weaker concrete, maybe a C8 or C10 below the crushing zone of the footing, or perhaps we could use precast blocks to assist with the uplift rather than bolts. This final example here then is from HS2 again. It's a polystyrene filled ramp with a concrete topping slab. What we did is we poured the concrete topping slab as a precast unit for the piling rig, and we prioritized circular economy to enable the disassembly potential at the end of life and future value, the highest future value possible. The connections of this item, as you can see on the right-hand side, were designed to allow access to reversible connections between the structures, and we developed and issued an assembly and disassembly guidance in the form of a designer's risk assessment to prevent damage to materials and keep them as high up this waste hierarchy as possible. We avoided unnecessary treatments and protective membranes with supplier collaboration, and we also investigated reuse business models by sharing design information on these QR codes. These are obviously icons, but there's QR codes printed onto them, so that the next engineer knew what the previous life was for that item. And if this kit turned up in the back streets of Bradford in a wagon, the new whoever bought that kit knows the strength and the reinforcement and the concrete mix and everything about the previous life of that item. This was coupled with ensuring that the design stayed within the elastic limits for full reuse of the original product in terms of the polystyrene. It's a good news story in a way, but we've also got to be really careful that in temporary works, the higher cement content that we put into this precast units to allow for durability and the higher strength polystyrene blocks that we use to remain way within the elastic limit, if these are now not reused and they are sent for energy recovery or recycling, that's wasted carbon. So we need to be really sure that we understand the end of life and that we balance the various end of life scenarios in our calculations. So, as I said before, it's not possible to meet net zero without future technological breakthroughs. And in temporary works, we have a perfect innovation breeding ground. But still, innovation is not happening. And where it is, it's usually in people's own time or on their overheads. And why? It's baffling. This is my sort of diagram to try and explain. So I think there are no benefits to our project from innovating. We're saving future carbon for the whole industry. I can't take it off my carbon budget for the project. There's also no funding. Any funding that is available is normally for a specific client line item like the £150,000 highway fund for treatment surfaces, for surface treatment. And there's also a lack of collaboration, which means that individual companies are working with their supply chains or a single university. A survey of over 61 UK councils, and it found only 4 thought that working with universities encouraged innovation. Working with other businesses and their supply chains through working groups like the Temporary Works Forum rank joint highest among the English Council local authorities. The funding here will not come fast, and we need to start now. So let's focus on collaboration and quantification as the driver and the enabler to change. To back up my argument, don't just believe me, that there's no sort of current innovation incentive. Here's another key incentive to innovation, BREEAM innovation credits. But on the BREEAM innovation portal for infrastructure, there are none in the past 2 years since starting. And there's only a handful from all contract types, verified by a BREEAM employee. We must remember,
that's 5 minutes warning, alert to go.
We must remember that innovation is new to the industry, one of a number of trials to get technology to the next commercialization level, and it often involves taking calculated risks, challenging the status quo, and pushing boundaries to achieve positive change. It's our duty to help those innovators as big companies, and we can't do it alone. It needs to be collaborative and joined up. A client I currently work with had to purchase 9,000 carbon credits costing £650,000 to offset their emissions. But later, they found out that they could divert a large proportion of this using carbon insetting, which is research and development within their supply chain, not external. The example that I've shown here is a lithium battery take-back scheme. And the lithium batteries went to a local lithium recycler and then fed back into the client's supply chain with their industrial ceramic process. Lithium lowers the firing temperatures and thermal expansion of kilns and increases the strength of ceramic bodies. And it also, if you add it to glaze, improves the viscosity for coating and the glaze's colour and strength. Closer to home, a past 2080 case study shows HS2 impacts well beyond the project boundary and well into the future. So why can't all projects do something similar? Why can't this incentive as presenting carbon savings against our carbon budgets be used on all projects from a grassroots innovation? Sometimes the trial doesn't save carbon, so there really is no incentive. Let's take this basalt reinforced slab, which isn't temporary work, so we've got to follow the UK codes. We may need to use steel and basalt rebar together to keep crack widths within UK standards. We may need to follow the minimum cement contents of BS 8500. But can we still present the savings as if the trial was conducted in full over the whole project? Especially if we're genuinely saving the supplier and helping them get to that next level of commercialization. Or if we're helping an app supplier, for example, build up a data bank. Even better, why can't we just present the savings of the whole sector should the commercialization happen? For the disruptive technologies that Natasha just talked about, we should be able to quantify quite easily with companies like the Supply Chain School of dividing the sector reduction potential by the number of trials, and then we can present that as a project saving or as a project plus I. This is obviously a thought experiment, but We're not going to solve these challenges without working group collaboration. Innovation is an ongoing process that thrives on iteration, learning, continuous improvement as an industry. So please join the Temporary Works Forum working group. We have a duty to work together and produce guidance for smaller SMEs without R&D funding. And let's write it for our little corner of the world. But more importantly, let's work with collaboration hubs such as i3P to use Temporary Works as a springboard to innovation for the whole industry. i3P is free for SMEs, and most big companies are already members for infrastructure. And it uses Innovate UK as the secretariat. Thanks for listening. Here are some useful resources and references that I've touched upon in my talk. I hope you find interesting.